Out in the vastness of interstellar space, humanity's farthest messenger journeys through the cosmos. Launched back in 1977, NASA's Voyager 1 stands as a pinnacle achievement in space exploration. This mission not only revolutionized our understanding of Jupiter, Saturn, and their myriad moons, but it also provided us with our initial, up-close view of the enigmatic and awe-inspiring planets Uranus and Neptune. As you watch this video, consider that the two Voyager probes are still active, voyaging into interstellar space, a realm untouched by any human-crafted object before. However, amid their trajectory into this uncharted territory, something unsettling is unfolding aboard one of NASA's iconic 20th century spacecraft. It captures eerie signals from interstellar space. Does Voyager merely encounter an unknown force? Or are these signals messages from extraterrestrial beings? And if so, are they friendly greetings or potential threats? Join us as we delve into the unimaginable journey of Voyager and the perplexing signals that have intrigued scientists for decades. Since their launch, Voyager 1 has traversed over 15 billion miles, while Voyager 2 has surpassed the 12 billion mile mark. Take a moment to reflect on the vision that sparked Voyager's creation, its monumental achievements, and its lasting legacy. Contemplate how these two probes and their discoveries have inspired subsequent missions and continue to shape NASA's endeavors today. In quieter moments, imagine a distant future, billions of years from now, when our sun evolves into a red giant. At that point, Earth will no longer be habitable, and humanity will have sought refuge on another celestial body, following the path blazed by the Voyager missions. It is both humbling and inspiring to envision that even in that distant era, the Voyagers will remain Earth's ambassadors, each serving as a time capsule from an era when intrepid explorers on our pale blue reached out to the stars beyond. The scientific contributions of the Voyager missions are not the only captivating aspect. The probes themselves have captured the world's imagination by carrying greetings for potential extraterrestrial civilizations in the form of the Golden Records. While Pioneer 10 and 11 carried simple metal plaques, Voyager's Golden Records were far more ambitious, filled with images and sounds offering a snapshot of Earth's diverse life and culture to any potential discoverers. The Voyager mission stands out as one of NASA's most ambitious endeavors, collectively visiting more planets, discovering more moons, and capturing more images than any other spacecraft in NASA's history. The question arises, why were there two Voyagers? In the early days of NASA flight, systems often encountered anomalies that necessitated safe mode, shutting down instruments until further commands were received. Given the fly-by nature of the Voyager missions, anomalies could lead to missed encounters and lost scientific opportunities. Thus, having two spacecraft increased the mission's chances of success, a strategy later echoed in the Mars exploration rovers, Spirit and Opportunity. Reflecting on their grand tours of the solar system, the Voyagers provided invaluable insights through tens of thousands of images and measurements, fundamentally altering our comprehension of the outer planets. For instance, at Jupiter, they offered our initial detailed insights into the planet's atmospheric dynamics, revealing the counterclockwise rotation of the Great Red Spot and its interactions with smaller storms. The Voyager missions marked significant milestones in space exploration, particularly with their groundbreaking observations of our solar system's outer planets. Notably, they were the first missions to detect a faint, dusty ring encircling Jupiter. Delving into Jupiter's moon Io, they unveiled its volcanic activity. Additionally, the linear features on Europa hinted at a potential subsurface ocean, and Ganymede claimed the title of the solar system's largest moon. As the spacecraft journeyed into interstellar space, past Saturn, they scrutinized the composition and structure of its atmosphere. Voyager 1's observations of Titan's thick haze led to the hypothesis of liquid hydrocarbons on its surface, a notion later confirmed by subsequent missions. The missions also identified gaps and waves within Saturn's rings. While Voyager 1 discovered three previously unknown moons, Atlas, Prometheus, and Pandora, Voyager 1 continued its voyage beyond the solar system, while Voyager 2 set its course for Uranus. At Uranus, Voyager 2 revealed 11 new moons and 2 undiscovered rings. However, certain phenomena, like Uranus's peculiar magnetic field and the consistent temperature across latitudes, remained puzzling. Voyager 2's final destination, Neptune, unveiled 6 new moons and rings. The spacecraft studied Neptune's composition and magnetic field and even identified volcanic vents on its massive moon Triton. Ultimately, both Voyagers embarked on a trajectory into interstellar space, where they breached the heliopause, the boundary where the solar wind yields to the interstellar medium's pressure. Voyager 1 officially entered interstellar space in August 2012, a discovery confirmed by analyzing electron oscillations during a solar eruption. This revelation contradicted expectations, as interstellar space exhibited higher electron density than just inside the heliosphere. The departure date was pinpointed through electron oscillations and a significant drop in solar particles on August 25, 2012, coincidentally the day Neil Armstrong passed away. At this point, Voyager 1 was 11.5 billion miles from the Sun. Interstellar space, the vast expanse between stars, is not devoid of matter. Approximately 70% consists of hydrogen, while helium makes up about 28%, both originating from the Big Bang. The remaining 2% comprises heavier gases and dust formed within stars and released into space by supernovae. Despite its sparse nature, the interstellar medium is vital, serving as the birthplace of stars, emphasizing its crucial role in the cosmos. The presence of thick and thin regions in the interstellar medium is crucial for the formation of stars. These regions, known as molecular clouds or stellar nurseries, are where stars are born. Initially, the universe consisted of simple elements like hydrogen and helium. However, as stars aged and underwent supernova explosions, they released more complex elements into interstellar space. This process allowed for the formation of stars with planets, marking a shift from the early universe when planets were non-existent. Molecular clouds are vital in this process, acting as the breeding grounds for new stars. The evolving elements in stars' interiors contribute to the increasing complexity of the materials in interstellar space. As a result, planets like Earth with the potential to support life have emerged. Voyager's venture beyond the heliopause, the boundary where the solar wind gives way to interstellar space, marked a historic moment. Voyager became the first human-made object to explore this uncharted territory, where no spacecraft or human-touched object had ventured before. Scientists anticipated groundbreaking insights into space exploration and the fundamental question that has fascinated humanity for centuries. Are we alone in the universe? As we delve into the vastness of the cosmos, the discovery of exoplanets, particularly those in Earth's size range and within habitable zones, has intensified the search for extraterrestrial life. The Drake equation, though with many unknowns, offers hope for determining the existence of intelligent civilizations. Despite the immense potential for life in the universe, the apparent silence, known as the Fermi paradox, raises questions about why we have not yet encountered extraterrestrial intelligence. Voyager 1's journey into interstellar space has yielded valuable data, revealing intense cosmic radiation and illustrating the interaction between charged particles from the Sun and those emitted by other stars. Despite its age, the spacecraft continues to astonish engineers. A notable example is in December 2017, when Voyager 1 successfully employed its backup thrusters, and used since 1980, showcasing its resilience and potential for extended operational life. As we stand at the crossroads of the search for life beyond Earth, our increasing technological capabilities offer hope that we may one day find answers to the mysteries of the cosmos. The Allen Telescope Array in California recently achieved an extraordinary feat by detecting a signal from NASA's Voyager 1 probe, launched 46 years ago and currently hurtling toward the outer edges of our solar system, well beyond the orbit of Pluto. The observatory, dedicated to the search for extraterrestrial life, utilized 20 of its 42 dish antennas, each over 61 meters wide, to make contact with Voyager 1. The telescope recorded 15 minutes of stored data on a disk, but the nature of the signal remains undisclosed. Speculations about the signal range from encounters with mysterious forces in space to the unsettling notion of aliens hijacking Voyager 1. Some even suggest that the signals are messages from higher civilizations to humanity, leaving the nature of these messages uncertain, whether they bring a friendly greeting or pose a potential threat. As Voyager 1 continues its journey, about 15 billion kilometers away from Earth, it is still being tracked by NASA's Deep Space Network. Its data transmission rate remains modest at 160 bits per second. Despite this limited data transfer speed, the probe, powered by a device converting plutonium's radioactive decay heat into electricity, has provided invaluable information. However, with the power output decreasing by about 4 watts annually, NASA faces challenges in maintaining Voyager 1's functionality. Triage measures have been implemented, including turning off the cosmic ray detector's heater, which was once crucial for determining heliopause transit. Although the last 2 instruments may persist for a few more years, the diminishing power output is a critical factor. Looking ahead, the Voyagers may last only a couple of years, perhaps extending into the 2030s if everything goes well. Yet even after their instruments are silenced, these spacecraft will continue their interstellar journeys. In approximately 16,700 years, Voyager 1 will pass Proxima Centauri, our nearest neighboring star, followed by Voyager 2 in 36,000 years. Both will continue to orbit the galaxy for millions of years, outlasting our sun's collapse and the demise of the heliosphere. These iconic spacecraft may, in their travels, convey a final message encoded on golden records composed of copper coated with gold and sealed in aluminum covers. These records carry images, sounds, and messages designed to give a sense of Earth. Although they were meant to last for perhaps a billion years, the actual survival depends on external conditions, with a potential threat being dust grains in space. Dust particles could slowly erode the spacecraft's surfaces over time, presenting a challenge for the long-term preservation of the Voyager mission's artifacts. The possibility that the gravity of interstellar clouds could influence the trajectories of the Voyager spacecraft has been considered. These massive clouds, concentrated with substantial mass, might bend the spacecraft's trajectory, leading to potential new orbits, sometimes even deeper toward the galactic core or farther out. However, both Voyager spacecraft carry golden records with engraved information on their sides, tucked away against their bodies, minimizing the risk of erosion in the next 5 billion years. A time frame where modeling becomes challenging, the Voyagers are expected to survive at least partially intact. This durability extends beyond the Milky Way's anticipated collision with the Andromeda Galaxy, a merger that will reshape the galaxy's structures. As the galaxies collide and their spiral shapes are distorted or potentially destroyed, the Voyagers might be caught up in this chaotic merger. The golden records on both Voyager spacecraft are predicted to endure for over 5 billion years, partially intact. During this time, the Voyagers might vicariously explore the galaxy, visiting stars within approximately 150 times the distance between Earth and the Sun. Notably, they might pass through the outskirts of star systems, possibly encountering stars that don't yet exist or are yet to be born. The Voyager's fate depends on the conditions during the galactic merger. The collision might propel them out of the newly formed galaxy, though they would remain in the galactic neighborhood. The main threat to the golden records at this stage would be collisions with high-energy cosmic rays and occasional impacts from hot gas molecules. Trillions of years into the future, the Voyagers would drift through a radically transformed galaxy. By then, most main sequence stars would have exhausted their fuel, leaving a dark cosmos populated mostly by black holes and stellar remnants. Supernovae, resulting from rare collisions between these remnants, would provide the only significant illumination in this epoch. As we contemplate this distant future, the Voyager's records may serve as witnesses to isolated flashes of light in a dark, unrecognizable galaxy. The information gathered from these records could offer insights into the cosmos during this epoch as the Voyager probes continue their journey through interstellar space. They are not only a testament to humanity's ambition and curiosity, but also a profound symbol of our desire to understand the universe. Their missions have taken us beyond the boundaries of our solar system, providing invaluable data on distant planets, moons, and cosmic phenomena that were once unimaginable. However, their journey is far from over. While their instruments may eventually fall silent, the Voyagers will continue to drift through the vast expanse of space, carrying with them the legacy of humankind's first foray into the cosmos. The data collected by the Voyagers has contributed immensely to our knowledge of space, enriching our understanding of cosmic radiation, magnetic fields, and the structure of the heliosphere. The probes have provided insights into the outermost reaches of the solar system, including the outer planets, their moons, and the interaction of the solar wind with interstellar space. This wealth of information has been crucial not only for scientific research but also for future space exploration. As we develop more advanced technologies and consider sending missions to distant exoplanets, the lessons learned from Voyager's journey will play a key role in shaping our approach to exploring other star systems. Despite the Voyager's age and the diminishing power they have left, the probes still offer hope for continued discovery. With each new milestone in their mission, the spacecraft remind us that the thirst for exploration is boundless, and the universe holds mysteries that are worth the effort to uncover. Whether their journey ends in a quiet drift through the galaxy or in the eventual discovery by an alien civilization, the Voyagers will forever stand as beacons of our shared human endeavor to reach beyond the stars and connect with the cosmos. In the far future, when human civilization has long since moved on to other realms, the Voyagers may remain silent emissaries of a long-gone species, still traversing the infinite void, waiting for another civilization to discover their messages from an ancient world. The golden records they carry will endure as an enduring legacy of humanity's place in the universe.